Today, I will learn how to find the constant between two or more ratios in a word problem. Today, I will learn how to find the constant between two or more ratios in a word problem. That's what our focus is today. So let's go ahead and start off with a review from last time. Last time we just had one problem, one real thing to worry about. So we're going to do an example of that. Here's our problem. Last summer at Camp Okie Fun Okie, the ratio of numbers of boy campers to the number of girl campers was 8 to 7. Notice that boy campers is blue, the 8 is blue, girl campers is red, the 7 is red. Since I read right to left, and I read the numbers right to left, boys comes before girls, so the 8 goes with boys and the 7 goes with girls. If there were a total of 195 campers, how many boy campers were there? How many girl campers? So my ratio is 8 to 7, and I need to figure out, again, what my constant is. But last time when I figured out the constant, I knew just how many boys there were, how many girls there were. This time, I'm comparing it to the total amount of campers. So in total, there are 195 campers. So 195 campers. And I'm going to divide that by 15. Where did I get 15, you ask? Well, 8 plus 7 is 15. And when I divide 195 by 15, I get the answer of 13. So every box needs to be 13. 13 times 7 is 91. That means there are 91 girl campers. Like I said, 91 girl campers. And then I have 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 boxes of boys. So I'm going to have 13 times 8. And 13 times 8 is 104. If I wanted a quick way to do it, I could have just added 13 to the 91, and that would also give me 104. And that's 104 boy campers. So how many boy campers were there? 104. How many girl campers were there? 91. And of course, I'd want to write this out as a complete sentence. So let's go ahead and do that now. There were 91 girl campers and 104 boy campers last summer. And there, I've got a great answer. Okay, now's when things get a little trickier. Instead of comparing just one set of numbers, we have a set of two different occasions. One first, then the second one. So we have Saturday night, we have Sunday night. Let's go ahead and read what our problem is first. The Business Direct Hotel caters to people who travel for different types of business trips. On Saturday night, there is not a lot of business travel, so the ratio of the number of occupied rooms to the number of unoccupied rooms is 2 to 5. All right, so that's the first piece of information we need to write down is 2, and that's going to be the occupied rooms, to 5. 2, 2, T-O, 5. And the 5 is going to be the unoccupied rooms. Unoccupied rooms and occupied rooms. However, on Sunday night, the ratio of the number of occupied rooms to the number of unoccupied rooms is 6 to 1. So now on Sunday night, 6 for every 6 occupied rooms. That looks like 60. For every 6 occupied rooms, there are one unoccupied room. So, what am I going to do with this? Well, let's keep reading. Due to the number of business people attending a large conference in the area, if the Business Direct Hotel has 432 occupied rooms on Sunday night. 432 occupied rooms on Sunday night. So I know the total of occupied rooms on Sunday night. That means occupied, unoccupied. How many unoccupied rooms does it have on Saturday night? Whoa! On Saturday night. I can figure out Sunday night easy, but how am I going to figure out Saturday night? Let's start one bit at a time, shall we? I know how to solve to find out how many occupied rooms there were on Sunday night. So let's go ahead and let's draw our diagram. So we have our tape diagram. And we have 6, so there's middle. I'm going to do 1, 2, 1, 2, and fill in all of these guys because they don't matter. All right. And then go back to this. So 6 is going to have to equal 432. So I have 6 boxes. Let's see how many go in each. So 432 divided by 6. See, 6 can go into 43 7 times. That gives me 12. So 6 can go into 12 2 times. So 72. That means every box is going to have 72. So let's go ahead and write in our 72. All right, so I have 72 in each box, which means there are 432 occupied rooms and there's 72 unoccupied rooms. How many rooms are there altogether? Well, let's add 72 to my 432 because I have my one other section here. So it's 4, 10, carry the 1, 504 total rooms. Now I have plenty of information to solve my problem over here. So let's see, we've got this. 1, 2, 3, 4, 5. Okay, and we've got 2 circles that really count, 2 boxes that count for the 2. I don't want you to think that's a 0, so I'm going to erase that. It's just occupied. All right, so there's 2 occupied rooms to every 5 unoccupied rooms. Now that's pretty bad. So let's see, our constant was 72. So let's write in our constant of 72. "72, 72, and 72. So, constant's got to be the same, right? Let's find out. So how many unoccupied rooms does it have on Saturday night? So unoccupied rooms is going to be 5 times 72. 5 times 2 is 10. 5 times 7 is 2 times 5 is 10. 7 times 5 is 35. Carry the 3. Nope, just put it right there. Add it together. So there are 360 occupied rooms on Saturday night. And that would mean there are 2 times 72 is 144. So 360 plus 144, does it add up to 504 rooms? Let's check. 4 plus 0 is 4, 10, 504 total rooms. Perfect. So, how many rooms were there? Let's go ahead and write it out as our sentence now. There were 360 unoccupied rooms on Saturday night. The key here is that you've got to keep them, the constant stays the same between the two different, even though our ratios change, our constant stays the same between the different ratios. So even though 2/5 does not seem like it could have anything to do with 6 to the first, in fact, 2 plus 5 is 7, 6 plus 1 is 7, so the number of boxes never changes, just the arrangement of them changes. And I hope that helps you with a very tricky problem, and that is why that is spicy, spicy math right there. Go ahead and watch this video as many times as you like, and when you're ready, move on to the game. It'll show you a different way of working to finding the constant using algebra. Boom, boom, boom. All right, have fun.